Okay, so this week we're going to learn about linear equations and linear relationships, and we're going to kind of review how to write a linear equation from different representations. So the first thing we want to look at is, what is a linear equation? A linear equation is an equation that when you graph it, it creates a straight line. So what that means is, if you were trying to graph an equation on a graph, it's not going to have any curves like that. It's going to just be a straight line. Okay, so linear equations, there are three different forms of linear equations. There's three different ways they can be written. In 7th grade accelerated math, we only dealt with slope-intercept form. In algebra, you'll deal more with point, slope, and standard form. So really all we're going to focus on is this y equals mx plus b. I just kind of wanted to give y'all, make y'all aware that there are two other forms that you will see in your future. So I want to review what slope-intercept form is. So we know that it's y equals mx plus b. If you'll remember, the y represents the y value in a set of ordered pairs that would fall on the line. The m is the slope of the line, which is also the steepness. The x is the x value in a set of ordered pairs. And the b is the y-intercept, which is the place where the line crosses the y-axis. So these are all really important things for you to know. If you look on your formula chart, your 8th grade one that should be glued into your spiral, this y equals mx plus b is on there, so you don't forget it. All right, so now we're going to review slope. So there's three different things that we need to do to find slope. We need to know how to find slope from a graph, from a table, and from 2 points. So the first thing we're going to do is I'm going to show you how to find it from a graph. So on a graph, we need to select 2 random points that fall on the line. Now, it's really important when you're selecting those points that you're choosing points that are like perfectly on the line. So I'm choosing these 2 points, specifically these two, because I know that they fall perfectly on where there's an x and a y value that are whole numbers. So now what we do is we do rise over run. So that means I'm going to start at this point and I'm going to go up. I'm going to go up 1, 2, 3. Hold on. We're going to start this over so that it looks better. Okay. So we're going from this point to this point. So I'm going to go, before I start counting, I want to help you remember that if you go up, it's positive. If you go to the right, it's positive. If you go down, it's negative. And if you go to the left, it's negative. So we're going to go rise over run. So it doesn't matter which point you start with, but I'm just going to start with the bottom one because that's how I remember. I'm going to rise 1, 2, 3. So I rose 3, I went up 3, so that's plus 3. And then I'm going to run 1. And I went to the right, so that's plus 1. Now if I do rise over run, I get 3 over 1, which when I simplify is just 3. So the slope of this line is just going to be 3. All right, now let's look at finding slope from a table. So to find slope from a table, we want to find the change in y over change in x. Remember that little triangle means delta, which is another word for change. So if I want to find the change, let's say I want to find the difference, I'm going to choose this point and this point. I like dealing with positive numbers because less integer mistakes are made, but you can choose any point, and when you reduce it, you will get the same number. So from 0 to 3, I add 3. So that's my change in x because this is the x values. Now from 8 to 20, I add 12. Now this is my change in y because these are my y values. Remember, the y always goes on the top when you're doing slope. It's always y over x. So I'm going to have 12 over 3, which when I simplify, both of these can be divided by 3. So that's going to be 4 over 1, which is 4. So the slope of this table, or the line represented by this table, would be 4. All right, now we're going to find them from an ordered pair. So we use the slope formula to find slope from 2 points. That would be this right here. This is on your formula chart where it says slope and it says m equals y2 minus y1 over x2 minus x1. The first thing that we want to do is we want to go through and label these. So I'm going to say this is x1, this is y1. Remember, when we have an ordered pair, it's always x comma y. So I'm just saying that this is the first ordered pair and this is the second. It doesn't matter which one you choose, but it does matter that if I'm choosing the first set to be 1, then both numbers have to be 1. So it's going to be x1, y1, and then x2, y2. The reason we label them is so that when we plug them into our formula, it's a lot easier for us to just move the numbers down and not get confused. Notice that it's y1 minus y2, or sorry, y2 minus y1. It's not addition. So it always has to be subtraction. So if I have y2 is 4 and I subtract y1 is negative 5. So this is how I would write that. 4 minus negative 5. Then x2 is 1 and x1 is negative 2. So it's going to be 1 minus negative 2. So if I do 4 minus negative 5, remember you add the opposite. So you keep change. Now I have 9. And then I have 1 minus negative 2. I keep change. I have 3. 9 over 3 is going to reduce to 3. So my slope for this ordered pair is going to be 3. Things to remember. You have to have your slope be in an improper fraction or a whole number. No decimals, no mixed numbers. When I say simplify, I mean put the number in its simplest form, but do not change it to a mixed number. We don't want mixed numbers. Mixed numbers are very hard when we go to graph our equation. Always simplify. All right, now we're going to review y-intercept. So to find y-intercept from a graph, we look at the point where the line crosses the y-axis, which is really easy, right? So this is my line. It crosses my y-axis right here. So that means my y-intercept is going to be 1 because that's where it crosses the y-axis. Now, to find y-intercept from a table or set of ordered pairs. Now, this is very clear. It says when the x value of 0. When you have an x value of 0 in a table or a set of ordered pairs, then you can very easily pick out the y-intercept. When you don't have an x value of 0, it gets a little bit more complex. So we're going to show you that in a moment. But right here, I have my x values and I have 0. The y value that corresponds to that when x is 0 is 8. So that means my y-intercept is 8. So that's pretty self-explanatory. Now we're going to go into finding the y-intercept from a table or set of ordered pairs when given x value of 0. That's supposed to say when not given an x value of 0. We're just going to add that in. Okay, so we have to use slope-intercept form to solve for the missing number, or b. So I just happened to use the same points that I used earlier, but I'm still going to show you exactly what you would do start to finish. And I have a few examples of this because this one might be kind of new. We touched on it, but we didn't go into it a lot. So this is going to be x1, y1, x2, y2. We have to start by finding the slope, okay? So I'm going to do 4 minus negative 5 over 1 minus negative 2. I get 9 over 3, so my slope is 3. So if I want to put this in y equals mx plus b form, it's going to be y equals 3x plus We don't know what our b is, right? So what we have to do is we have to choose one of our ordered pairs up here and plug it in for the y value and the x value in our equation to find this missing number. So I'm going to erase the ink on my slide just so that I can have more room. So if I'm going to choose 1 and 4 because 1 and 4 are easier numbers to deal with. So I know that 1 is my x value and 4 is my y value. So I'm going to do 4 equals 3 times 1 plus b. Why do I have this 3 there? That's because I already know that 3 is my slope. So I have to put the 3 there in order to have only one missing number. So all I did was I took the y equals 3x plus something, and I put the 4 in for the y and the 1 in for the x. Okay, so now I'm going to do 4 equals 3 times 1 is 3 plus b, subtract 3. So b is going to be 1. So my final equation is going to be y equals 3x plus 1. Okay, we're going to do a few more examples of this, I think. Nope, we're going to do one more. Okay, so first things first, I need to find my slope because the things I need are m and b. Okay, so I'm going to use, again, these two because they're the easiest. So from 1 to 2, I add 1. From 5 to 11, I add 6, right? So if I do my y over my x, I get 6 over 1. So my slope is 6. So when I plug this into my equation, I get y equals 6x plus something. So I'm going to choose this 1 and 5 to be the ones that I plug in. Because, again, I want to choose the easiest number. I don't want to make this harder than it has to be. So my y value is 5, so I'm going to say 5 equals 6 times 1, because 1 is my x value, plus b. Okay, so I'm going to have 5 equals 6 plus b, because 6 times 1 is 6. Subtract 6, subtract 6, b equals negative 1. So now when I rewrite this equation, it's not going to be plus b, it's going to be minus 1. Y equals 6x minus 1 because my y-intercept is negative 1. So we change that addition sign to a subtraction sign. Instead of saying plus negative 1, we're just going to say minus 1 because that's easier. All right. Now we're going to put it all together. So once you have found the slope and the y-intercept, you're going to put those into slope-intercept form. So these were just examples that I came up with. If we have slope equals 4 and y-intercept equals 5, then our equation is going to be y equals 4x plus 5. I just put those in. If my slope equals negative 1/2 and my y-intercept equals negative 10, I'm going to have y equals 1/2 x minus 10. Negative 1/2, negative 10. Okay. Slope equals 2. Y-intercept equals negative 7. Y equals 2x minus 7. Positive 2, negative 7. So all we're doing is plugging those values in. If you have any other questions, reach out to your teacher and we will help you. And that is the end.